third vlog on sailboat maintenance. Today we're going to be talking about engines and engine systems. Specifically, we're going to be talking about the raw water cooling system. But an engine is made up of three primary systems. Okay, and those primary systems are the fuel system, the cooling system, and the lubricating system. So today we're going to be taking the opportunity to talk about cooling and how cooling works, and on later videos we'll be talking about the lubrication and the fuel system. Okay, so let's talk a little bit about the coolant system on a boat and how it works. So here's my engine. And it's a combustion engine, and the effect of a combustion engine is it generates heat as well as motive power. And we need to dissipate that heat, because if we don't, the engine is going to overheat and effectively seize up. So how do we do that? Well, in the same way that a car's engine is cooled, we have a coolant system that runs through the engine. Okay, and that coolant system absorbs the heat from the engine itself, from the block, from the head, and absorbs that into the coolant system. Okay, so that's great, but once that coolant would have heated up, it will just become the same temperature as the engine. So what we need to do is dissipate that heat, and how we do that is with a pump. Okay, here's your pump. And that drives coolant through the engine. Okay, that coolant pump pumps up into in a car, the radiator, okay, and that radiator is there to dissipate the heat. So the airflow across the radiator, the heat is pushed out of the coolant into the surrounding air, and effectively cools the coolant. Okay, that coolant, once it's cooled, is then returned back to the engine in a cooled state, so that it can cool the engine again. Okay, and this is what we call a closed loop system. Okay, so the coolant is flowing through this closed loop. Okay, it's important to note there's normally a little reservoir where we fill up the coolant. Okay, and this is a pressurized system, so there's normally a pressurized cap here, typically about 13-14 psi, and that means that the coolant, because it's pressurized, will actually boil at a higher temperature. Okay, so the net effect of that is the coolant doesn't boil, okay, because it's in a pressurized system. So really simple system, just like you have on a car. As I say, coolant flowing around through the engine, being passed and pushed by the pump through the radiator. Air is passing through the radiator, so that cools the coolant inside the radiator, which is then returned back to the engine. Really simple, and that's just like you have on a car. So on a boat, let's put this engine on a boat now. On a boat, the system works slightly different. There's some water. Okay, and the way it works on a boat is we have something different. We don't have a radiator, we have a heat exchanger. Okay, and that heat exchanger basically wraps what was the radiator in a jacket, and inside that jacket is our raw water, okay, the water from outside of the boat, and that water absorbs the heat from the coolant through the heat exchanger, and allows that cooled coolant from the primary circuit back into the engine. So to do that, of course, we now need to have some flow of coolant, of raw water through this heat exchanger, and we do that with another pump. Well, let's put this pump on here. Okay, this is our raw water pump. And that raw water pump is a shaft-driven pump in the same way that the primary coolant pump is, and that drives water through the heat exchanger. There we go, going through the heat exchanger. Okay, now where does it get its water from? Well, it gets its water from a through hole in the hull, which is typically protected with a seacock. Okay, and that enables us to turn the flow of water off and protect the boat when we're not at it, we're not with it. It'll come up to a strainer from the seacock. Okay, and then from the strainer to the pump. Okay, so the job this time of the strainer is a filter. Okay, this pump can't push large particles through the system, and indeed you wouldn't want large particles passing into the heat exchanger because it would block it. So this strainer is there to filter out large debris that may be sucked in through the seacock. Okay, so just to recap, the raw water is coming in through the seacock, through the strainer, pumped by the raw water pump, and is passing through the heat exchanger. Okay, it's then typically passed into the exhaust system of the engine and is pushed out the side of the boat in the customary splashes that occur from the exhaust system, the wet exhaust system. So that is the key components of a cooling system for an engine. The key components being the primary circuit, drawn in blue here, which has a pump and a heat exchanger, and then the raw water system, okay, which has a seacock, a strainer, a raw water pump, again through the heat exchanger and dumped out through the exhaust system. So what can go wrong with this system? Well, we can have problems with a blocked entry here at the seacock, which prevents flow of the raw water. We can have a blockage in the strainer, again preventing flow. Okay, the raw water pump requires maintenance, and in the next part of this video we're going to go to my boat and have a look at the raw water pump and how to maintain it. And the rest of the system is pretty much maintenance free from the raw water system. You can get a blockage in the heat exchanger and you can take those apart. That's probably a reasonably specialist job, but maintaining upstream of the heat exchanger is a DIY task and something we should all know how to do. particularly when we're at sea, of course, when the access to our friendly mechanic, diesel mechanic, will not be easy. So they're the primary parts of the system as I've just described. What we'll do next is we'll go to my boat and have a look at that raw water pump. We'll have a look at the strainer and how to do the maintenance of the coolant system on a boat. So we're on my sailboat now, and we're going to take the opportunity to have a look at those key components of a coolant system for an engine. I've got a Beta 28 horsepower engine here on my sailboat. You may have a different manufacturer or a different type of engine, but those key fundamental components of the coolant system, which might be different on your boat physically, will still be there. And you should be able to trace your system out the same way we're about to with mine. So let's have a look at the engine itself and those key components. So let's start looking at the raw water system, with this the first component in that system being the through hull fitting with its associated seacock. You can see here that the seacock is in its closed position, but what's really important to note is the two Jubilee clamps that are holding this hose onto the fitting. Really important here that we maintain the integrity of these fittings. If they fail, then the boat sinks very quickly. Let's look at the next part of the system now, which was that strainer. So here's the raw water strainer for my boat. I've got a really simple one fitted here. Yours may be different, more complex, but they all fundamentally do the same thing, remember, which is to filter that raw water to ensure that no debris gets into the raw water pump. So let's have a look at the raw water pump next. So we'll follow the hose from here, my strainer, down to my raw water pump. Here's the raw water pump fitted here, and we'll be doing some maintenance on that shortly. The output from this raw water pump goes up and across the top of the engine to the heat exchanger, and we'll look at that next. Okay, so we're having a look at the top of the engine here. Here is the pipe from the feed from the raw water pump. It's coming across the top of the engine here and feeding into the heat exchanger. This here is the heat exchanger with those pipes. Remembering it's just like a radiator on your car, but instead of being surrounded by air to cool, it's surrounded by this raw water. Okay, so it's a big tank with the raw water in it, cooling the primary cooling system, which we'll talk about momentarily. So the feed going into the heat exchanger is here, and the coming out of the heat exchanger raw water is here, and it goes down and into my exhaust system down below. And that's the end of the raw water system on a boat. So now let's have a look at that primary coolant system and just talk about that. So here we are again, back at the front of the engine, just to look at the primary coolant system. Okay, so we can't see very much of it because most of the coolant system is surrounding the engine head and the block. But we do see it come out, and here it is coming out of the block, and it's feeding up into this here, which is the primary coolant pump. Okay, in this case belt driven, and using the same belt as is used to drive the alternator. Basically maintenance free. It's a metal impeller in there, which is very reliable. So the other part of the coolant system is the heat exchanger. So again, let's have another look at that heat exchanger from a slightly different angle. So here's the side of my heat exchanger, and remembering there's two types of coolant flowing through this heat exchanger. There's the raw water system and the primary coolant system. So the primary coolant system is topped up using this filler cap here, and it's important that we use the right mixture in here of coolant and fresh water, the correct strength. Coolant helps to prevent the water from boiling in your primary coolant system. Of course, the other thing that helps to prevent that is the fact it's a pressurized system, and that's why we've got a spring cap here on the top. Okay, now just have a quick look at mine. It's a 95 kPa pressurized system. So part of our maintenance is to just check that coolant's up to the top of this system here. Just put the cap back on. Really important not to take this cap off when the engine is hot. The system will be pressurized, and it will force out very hot liquid over you and will burn you. So really important safety feature or safety note is to make sure that you don't take this cap off when the engine is warm. So let's look at the first piece of maintenance of our raw water system, which is just to check and clean the strainer on the raw water system. So here it is on my boat, as we've already seen. Okay, really easy on my boat. Going to check that the seacock is in the closed position. Undo this wing nut. We'll put that to one side so we don't lose it, and then remove this lid. Okay, now I've not done this for about a month, so let's have a look. So what happens is there's a little basket inside here, and I can lift that out, and we'll see the contents of this filter. As you can see, I've picked up some, if I hold it, there we go. As you can see, I've picked up some weed and some reeds that just needs flushing out, but actually this is quite good. So I've cleaned the basket out now. The other thing I need to do is just make sure that the seal is nice and clean. There's an O-ring sitting on the top here, so I'm just using cloth, a little bit of water from the filter bowl, just to make sure I've not picked up any debris and dropped it onto this seal. So next thing to do is drop the filter basket back in. Thus, make sure that's sitting nicely within the bowl. Drop the cap back on. Just see that it's going to seat nicely onto that rubber washer, onto that big O-ring, and then just tighten up this wing nut back down onto the top. Okay, so it's important that this wing nut is tight, but not so tight that you either crack the lid or that you're not able to undo it in the event that you need to. So when we first start the system up in a little while, we'll have a look to see that there's no leaks from here. So I'm just going to dry that off, and that will help me see that whether there's leaks later on. So the next job to do on the raw water system is to replace the impeller on the raw water pump. And let's go through the process for doing that now. So here it is, my raw water pump. What I'm going to do is remove the top cap by undoing the 6 retaining screws. Really important that you don't lose these screws, so as you undo it, put them nice and neatly to one side, trying to avoid dropping them into the bilge. Again, as when we've done the strainer clean, I've made sure that the seacock is in the closed position. just steadily removing these cap screws. What we will do is we will lose a little bit of water from the pump when we remove this last screw. There we go. Just going to let that run into the bilge, and I can dry that off later. So now I've removed the cap from the end of my raw water pump, and the next thing to do is actually remove this impeller. You can see I've still got some water just draining out from the raw water system, mainly from what's held within the heat exchanger. So you can get a special puller for this, but I think most people manage in the same way that I'm about to do, with a pair of pliers. So I'm just going to reach in here and wiggle and pull the impeller off. So here's the impeller now. Here's the impeller now off of the system, and we'll compare that with the new one shortly. So as we look in, the next thing we need to do is look inside, make sure it's free of any debris. I'm also going to replace this O-ring on the front that comes as a part of kit. The kit parts, I'm just going to use the screwdriver just to gently prise out this O-ring. Now, I'm not saying that this O-ring needs replacing every time. Indeed, I don't think it does. But I've bought a kit this time, so I can replace the O-ring. You can buy just the impellers, and as long as you're getting a good seal on here, you don't need to replace the O-ring. Some pumps, older pumps, come with a paper gasket, and you would need to replace that each time. So I've got a bit of verdigris, a bit of corrosion going on this face, and I'm going to clean that up before I progress any further. The next thing we need to do is install the impeller, and we do that by applying some lubricant that comes in the pack to the blades. Some people say put an O-ring to compress the blades, but I find that if we just feed the impeller into the pump, twisting it in the direction that the pump will turn, it'll gradually feed its way in and drop in onto the spline. There we go, nice and nicely installed. A little bit more lubricant. These packs come with a very generous amount of lubricant, and I'm just going to apply a little bit to the O-ring to help seal that as well. Next thing to do is install the cap onto the pump. We do that by lining up the holes and finger tight the screws into the flange. It's important that we just use our fingers for this. The screws will be stainless steel and very hard, and the brass and the flange will be brass, and it's very easy to cross thread these very fine screws if we were using force from a screwdriver. So just starting these screws off with finger tightening, which is not the easiest because they're such small screws, but being very careful of course not to drop them into the bilge. Better to be a little slower and not spend half an hour recovering the screw from the bilge. So there we go, all finger tight, cap is a little loose still. I'm now going to use a screwdriver just to really lightly snug these down. Not cranking them home yet, just really tighten them down so the screw is sitting on the top of the cap. The next thing we need to do is tighten these up in a manner that pulls the cap down evenly onto the flange. The way we do that is we start at 12 o'clock and we come down to 6 o'clock, and then we go up to 2 o'clock, and then across to 7 o'clock, and then across to 5 o'clock, and then up to 11 o'clock. Okay, and I'm actually going to do that a couple of times, just gradually and evenly tightening this cap down onto the flange of the pump. And there we have it, a new impeller installed in our raw water pump. So one other thing on the raw water system that we haven't talked about previously is the sacrificial anode, which is here on my engine. Okay, it points into that raw water coolant system. And that needs to be checked every 6 months. It's been a while since I've checked mine. It's nice and easy, just with a spanner undo the anode from the housing. Some water may leak out, and that's it, or actually that's not it, because most of it's missing. The main bit that needs to be there is missing, and that obviously means I need to get a new one. So it should have about 2 inches worth of anode pointing at the end of this brass fitting. So another thing to add to the to-do list: get one of these, because I don't want to have one on board at the moment, and replace it. But for now, I'm just going to replace this into the housing and make a note. Okay, so the final thing to do now is just to test the coolant system. How I'm going to do that is by starting the engine and just observing for leaks, particularly here around the flange for the water pump and around the flange on the top of this filter strainer. So let's get this engine started and just have a look for leaks. The other thing that I am now going to do now is pop out and have a look at the back of the boat and just make sure that water is being ejected out of the exhaust. And that ends the maintenance of the raw water system.